Welcome to Code Map. Today we are going to discuss the Leetcode daily challenge, which is insert interval. This video will consist of three sections. In first section, we will discuss the question. In the second section, we will discuss the approach, and in the third section, we will discuss the C++ solution. Now, coming to the question, it is given that you are given an array of non-overlapping intervals where intervals I equal to start and end represent the start and end of the ith interval. It is saying that we will be given an array whose ith index will have a start and end value, which is the starting and ending of that ith interval. Now it is given that you are also given the new interval, which has a start and end that represent the start and end of another interval. We will also be given a new interval, and we have to insert that new interval into intervals at appropriate position. And it is also given that we can merge the overlapping intervals if necessary. For understanding this question, let us first understand what is merging the overlapping intervals. Let's say, for example, we are given with the intervals like 1, 4, 2, 5, and 6, 7. So here we can see that first interval starts at 1 and ends at 4. 1, 2, 3, 6, 7. We can see that first interval starts at 1 and ends at 4. And second interval starts at 2 and ends at 5. Here we can see that these two intervals are overlapping each other. So we can merge this interval, and the resultant interval will be 1 and 5. So after merging these two intervals, the resultant interval will be 1 and 5. Now, looking at these two intervals, we can see that these two intervals are not overlapping. So after merging these all intervals, the resultant interval will be 1, 5 and 6, 7. So this is our resultant intervals. Now let's understand how we can implement this. What we will do, we will take two variables start and end and initialize this two variable with the first interval, which is 1 and 4. 1 and 4. And now I will iterate this list from index 1. This is index 0 and this is index 2. I will iterate this list from index 1 and I will compare this 2 with this end value and check if this value is greater than 2, then we can merge these two intervals. So our e is greater than 2. So our new value of e will become this, which is 5. Now we will assign our e value like this. E equals to max of e comma this 5. Why I am using max? Because if our interval would like this, if instead of 4 it was 6, then we can see that these two interval overlaps. But if I will assign e with value 5, then it will say that our resultant interval is 1 and 5, which is not true, because our resultant interval will be 1 and 6. Means after merging these two intervals, we will get this as resultant interval and not this. So I will use max, which will take max of these two values. So if so the max of 5 and 6 will be 6. So our e will be assigned with 6. So I am using max. Now coming back to our test case, which was 4. Now the value of our e will be 5. 5. Uh, Now in the next iteration, it will move to the next interval. And again, we will compare the value of e with 6. And we can see that e is smaller than this starting value of the new starting value of this interval. So uh, these intervals are not overlapping each other. So what I will do, I will push this result into our result into our result, which is 1 and 5, and I will assign start and end as 6 and 7. Now in the next iteration, the loop will go out of the list, and our start is 6 and end is 7, and I will push this 6 and 7 into our result 6 and 7. Now we can see that this is our resultant after merging this interval. Now we have understood what is merging and how we can apply merging on the given intervals. Now coming back to the question. uh, Now coming back to the question, we will be given interval and new interval. We have to insert this new interval into intervals at the appropriate position and then apply merging that we have discussed previously. Now coming to the approaches. First, we will discuss the brute force approach. In brute force, what we can do that we will insert this new interval into our intervals and apply sorting on this interval, sorting in this interval, and then apply merging to this interval. The time complexity of this brute force approach will be n log n. Now coming to the optimized approach, which is of O of n. Now we will discuss how we can implement that. We will take this discuss. Now let's understand the logic with the given discuss. In this optimized approach, we will apply merge on this interval. Along with that, we will insert this new interval, a new interval into our intervals. We have discussed the merging logic previously that we will apply here. Now we will take two variables, start and end, and initialize it with 1 and 2. Now these are the index of this list 2, 3, 4. In the merging logic, which we have discussed previously, we were comparing this end value with the starting value of the next interval. But here we will do the same, but we will do one extra thing, that before comparing this e with the starting value of the next interval, we will compare this starting value of this interval with the starting value of new interval. If this new interval is smaller than this starting value of this interval, this means that this new interval comes before this. But here we can see that this new interval starting value is greater than the starting value of this new interval. This interval means this interval comes before this interval. So we will process this first. Now I will compare this e with the starting value of this interval, and we can see that e is smaller than 3, which means this interval doesn't overlap with this interval. So I will push this 1 and 2 into our resultant list 1 and 2, and I will assign start and end as 3 and 5. 3 and 5. Now in the next iteration, we will continue with second index, and again I will compare this interval starting value with the starting value of the new interval, and we can see that the starting value of this new interval is smaller than the starting value of this interval, means this new interval comes before this. So I will process this new interval first, and in the next iteration I will continue with the second index only. So I will compare this 5 with 4. And we can see that 5 is greater than 4 means these two interval overlap. These two interval overlap. So I will assign E as max of E and 8. And we have discussed why I'm using max. So the value of E becomes 8. Now in the next iteration, we will continue with the same index, which is 2 and 6 and 7, which is 6 and 7. Now we have processed the new interval, and after processing this new interval, we will assign this value with int max. This value with int max. Now we will compare E with the starting value of this interval, and we can see that 6 is smaller than 8. So we will assign E as max of 8 and 7, and we can see that 8 is max. Now in the next iteration, it will move to interval 8 and 10. Now again we will compare this 8 with this new interval, and we can see that it is new interval. The starting value of new interval is int max, which is very greater as it was already processed. So we will process this interval only. Now we will compare E with the starting value of this interval, and we can see that it is equal. So I will assign E with max of 8 and 10. So 10 is max, so I will assign E as 10. Now in the next iteration, it will move to interval 12 and 16. And again, I will compare this starting value with the starting value of new interval, and we can see that it is greater. So we will process this interval. Now I will compare E with the starting value of this interval, and we can see that E is smaller than the starting value of this interval, which means this interval cannot be merged. So I will push this into our resultant list and assign start and end with 12 and 16. Now in the next iteration, it will be out of the list, and our list is finished. So I will push this value into our resultant. 12, 16. So this is our resultant list after inserting the new interval and merging. Now let's see. Now we can see that the output matches. Now let's discuss C++ code. We have given the insert function, which has intervals and new intervals. First, what we will do, we will check if the size of interval is 0, then we will return new interval. Means if our interval list is empty, then our resultant interval will consist of only new interval. So here I am returning new interval. Now if the size of interval is greater than 0, then here I am declaring a resultant vector, and here I am checking if the new interval is smaller than the starting value of the intervals, means this new interval comes before all the intervals in the interval. Then what we will do, we will swap the first value of interval with new interval in new interval. Now here I have taken two variables, start and end, and assign this start and end with the first interval value from the intervals. And now I am iterating over the intervals, starting with index 1. Now, as we have discussed in the logic, I am comparing the new interval's first value with the interval which I am going to process, starting value of the interval which I am going to process, which is in the first case, which is 6. So if it is smaller, if the new interval is smaller than the interval which I am going to process, then we have to first process this new interval. Means this new interval comes comes first, then the interval, and the intervals, then the current intervals. Now, if this condition satisfies, we will come into this if, and we are checking if the new interval is if the starting value of new interval is lesser than equal to the end value of the interval, means the new interval means we can merge our new interval. So we are assigning E with the max between E and the end value of the new interval. And if this condition doesn't satisfy, means this new interval doesn't overlap. So what we will do, we will push back the start and end value and assign our start and end value with the new interval 0 with the starting and ending value of the new interval. And if this condition doesn't satisfy, it will means that a new interval doesn't come before the interval which I am processing now. Then it will check if interval starting value of the interval which I am processing is lesser than the end value, means the interval which I am processing is able to merge or not. If it is able to merge, then we are assigning end with the max of end and the end value of the current interval. And if it is not merging with the interval, then we are pushing the start and end into our resultant vector and assigning a start and end with the starting and ending value of the current interval. And after this loop, we have used this if we have used this if to check if the new interval doesn't lie in between our intervals, means this new interval lie at the end at the end at the end of this interval. This if is for this condition. Now, how we will know that whether this new interval was processed or not? While processing, we have means if new interval has been processed, then we have assigned the starting value of the new interval as int max, and at the end we are checking if the new interval value is lesser than int max, means the new interval has not been processed. So we will process it here. We will check if the new interval is able to merge or not. If it is able to merge, we will assign E with the max of E and the end value of the new interval. And if it is not able to merge, then we will push the start and end into our resultant vector and assign S and E with the starting and ending value of the new interval. And at the end, we are pushing back S and E into our resultant vector. Now let's submit this code. Now let's first run this code. Now we can see that it is passing all the given use case. Now let's submit it. Now we can see that the code has been successfully submitted with a runtime of 19 milliseconds and a memory of 17.1 MB. Thank you.